Welcome to part 2 of building a soil moisture monitor using an Arduino Uno and various bits and pieces. We have these two galvanized nails which are used as probes to go into the soil to measure the current. So the wetter the soil, the more current we get. We're going to try and make some music with that. Going to update to a larger breadboard today. We're going to end up with a bunch of components and wires, so probably a good idea that we upgrade to something with more space. I've got this Ethernet cable I'm going to be using. It's got these nice twisted pairs of wires, so we're going to be adding more probes today, probably just one. So the first step is to just move everything across from the smaller breadboard to the big one. Fairly simple stuff. Here's our 10k ohm resistor. We'll start off with the 5 volts. Plug that into the 5 volt rail and get the ground in there as well. If you're not sure how breadboards work, by plugging them into any one of those rails, it means that everything in the vertical row is now connected to that. So I can plug into any of those holes below those two sockets where I just plug them in and we'll get 5 volts or we'll get ground. So you can see here I'm plugging one of the probes into an existing socket which is connected to the 5 volts, and we'll just put it in the plant just for storage. And here's the probe that goes into, well, it did go into analog 0 and it still will. So I'm just going to plug that into its own separate row. We'll start at the bottom and work our way up. That in the plant just for safekeeping. And now we've got this 10k ohm resistor again, the pull down resistor, just to give us a nice steady signal that needs to connect from that analog 0 probe to the ground. There we go. And of course, we need to connect the analog 0 to the analog 0 in of the Arduino. Okay, so that's kind of replicated the setup we had on the previous breadboard. And now it's time to work on getting a second set of probes happening. So I'm going to get myself another patch cable here. Put this into analog 1. And we'll plug this into the second row from the bottom, moving up. We're also going to need another 10k ohm resistor. I did have to look up whether I could use the same resistor for all of the probes, but apparently I need one for each, which is fine. I've got 10 of them. Might need to get a few more if we get some more plants. So now I'm just connecting that row to the ground, the 10k ohm resistor. It's a little bit fiddly. It's looking alright. Now we need to start thinking about the probes and using that wire. So as I said, I have this old Ethernet cable here. I was trying to figure out how can I get these twisted pairs of wires out. Got the scalpel out. Don't know if that's a good idea, Tom. We'll give it a go. Let's have a look. Yeah, nah. One slip up there and there's my career done, so we'll put the scalpel away. Got the old skizzers. And that was kind of looking like it was going to be a pretty arduous and long process. So I ended up opting for this box cutter. Now I did a few experiments off camera, trying to find the safest and most efficient balance here, and this is kind of the technique I came up with. Perhaps there's a tool that could do this better. You can see if I just hold it like this and just pull with my left hand. If it does slip slightly, it's not going to go straight into my finger or my thumb. Then we can peel it open like this, which I found quite satisfying. And this took me about 10 minutes. That's probably maybe 3 or 4 meters long worth of cable. It took a bit of time, but I've got plenty of time for this project. So here it is. You can see we can just pull it all out. It makes a really good sound, but I had some music playing while I recorded this, and it will probably get this video copy striked. So next video I'll make sure I do it in silence so you can hear all the nice sounds. Kind of sounds like I won't do that again. Nice. And yeah, I've got a bunch of this, so this is really, really good stuff. It's long enough, it's twisted up, keeps things nice and neat, and it's color coded, so perfect. And we're recycling, or reusing, repurposing. So I need to check out what we're working with inside this wire. So I'm going to be stripping off the ends because I need to attach each one of these wires in the twisted pair to the end of those galvanized nails. Remember, we want galvanized nails so that they don't rust and they're still conductive. I imagine we will still get some build-up with current going through them over time, but it's alright, they're just nails, pretty easy to replace. I think they were $9 for 100. So I'm just going ahead and very carefully stripping this wire. Still haven't got myself a wire stripper yet. Haven't really felt the need to get a specific tool for this. Everything's very amateur here. If you do see something I'm doing wrong, or you have some suggestions on ways I can do things better, let me know. I'm very aware that I'm not a professional at doing this stuff. So here's the wire. To the other side. I need a bit more length. Let's grab a nail and see So yeah, decided that I do need a little bit more length there, as I want to solder it. I need copper to be soldered onto copper. The solder just doesn't stick to the nails themselves. So now we can go around 1.5 times or nearly 2 times, which is fully sufficient. Time to grab the super handy grabby machine. I imagine I'll get a bit more efficient and faster at this, because I'm going to have to do this, I don't know, 10 to 12 more times. Probably won't make a video documenting me doing this over and over and over. Maybe we'll do a kind of a 30-second time lapse or something. Okay, that's ready for soldering. And just a quick thought, I've got this ESP32 sitting around. I thought this could be a good option if we wanted to upgrade. The reason being it does have Wi-Fi on it. So we could connect this directly to my Wi-Fi and it would get rid of the need of having to plug the Arduino into the computer. Yeah, I think it doesn't have enough analog input, so we might need to multiplex it, but we can deal with that as we come to it. Also found this basic kind of screen sitting around. I thought this would be cool just to display some basic information. Be nice if this was just sitting in a little box and I can just look at it. We could probably get the ESP32 making some sounds as well, perhaps. Anyway, so I'm just testing this heat shrink stuff. Just making sure it fits. I don't have much of this left, so I'm going to have to get some more. That's good stuff. That's exactly what we need for this. That's to kind of secure the ends of the nails so that all the wiring is covered up and held in place. So we've got the soldering iron ready. There's a close-up of my forehead. Let's do some terrible soldering. Not quite warmed up yet. You might notice the reel-to-reel in the background. I picked that up for $40 a couple of weeks ago. Fixed it up. I've got some exciting plans with that. It was made in the 1960s in New Zealand. Really cool piece of machinery. And yeah, it actually works, so looking forward to doing some videos on that. Right, here we go. Little bit of solder on there. And number 2. Made a slight mess of that one, but never mind. We can hide it with that heat shrink. Right, let's get this the last little bit of heat shrink wrap cut up. And we'll slide it up from the bottom. Very good. Get the old over the top butane torch out. Nuke it a few times. And that's now hugged the top of the nail, and we should be nice and secure. On to number 2. Bit too much shoulder there. That's right, it still fits. Okay, that should be our second set of probes sorted. Well, at least this end of the probe. Let's have a look. Sometimes I do things off camera. Still getting used to this perspective. So that's what it looks like. They're pretty tough. Yeah. Then we can move on to the other ends and have to figure out how to make the other ends a bit more stabby so we can get them into the breadboard. Put the soldering iron away somewhere. So with the other probes, we had those kind of patchy, pluggy bits, which are quite hard and stiff, that you can plug into the breadboard without any problems. But yeah, this is just going to give us some kind of frayed copper wire, which you can't really just shove into breadboard hole. So I'll start by just stripping it off. So that's the long hard stabby thing, which would be the ideal thing to have. kind of having a look here to see if I can get one of these off. They seem to have a little piece of plastic which is holding it in. So I'm just trying to pull that piece of plastic up, see if I can slide it off. So it would be ideal if I could slide that off and just slide it onto the end of the wire. You can see there I've clicked the plastic off, and this is kind of what we've got. Don't know if we can focus that closely there. So you can see it's kind of crimped in there. Up a bit, Tom, up a bit. Oh. So I'm going to try my luck at removing that. It's a little bit too fine. Don't think I have the right tools to be able to get that off. I'll give it a good honest go. Once again, there's my forehead and messy hair. You'll be seeing that a bit in these videos. I'm just going to cut to the next part now because I muck around with this a lot and end up rage quitting. So what I've decided to do instead is just cut one of these at the wire part. And I'll just strip some of the wire off. And then we'll just connect that up to the probe wire. It would have been nice to be able to get things into the little stabby cases, but yeah, too much effort. If we do end up using something like the ESP32, again with a multiplexer, probably end up just soldering the wires directly onto the board. But we're still at kind of prototype, muck around, proof of concept stage. So here I'm using my super grabby things to kind of get these wires matched up. Now I could be, preparing these wires for soldering. What's the word for it? Where you put some solder on the wire before you try and connect them. Can't quite remember the word. It's a good practice, but I don't feel it's necessary for this one. As long as there is at least some sort of connection and a bit of tape, then I'm happy. Again, for the prototyping kind of botch things together stage, if I decide to get a bit more professional, I'll do it properly. There we go. Let's get another one ready. We're very close up now. I don't think I've ever seen my hands this close up. That's a lie. interested to know what people think of the slow pace of these videos is like. So this is just kind of a weekend project for me, and for me to turn this into, you know, maybe a 10-minute video from start to finish, there's quite a lot of work involved. There's a lot of editing and planning, and hang on, let's just look at this terrible solder job. Come on, you can do it. There's some people cringing right now. Come on. Here we go. Good enough. Take it away. Done. Yeah, so just kind of recording everything and then just narrating what I'm doing. It's quite easy for me. It's pretty much real time. Whereas I don't really feel like, you know, spending quite a few days editing and scripting and is worth it for these type of just hobbyist botch job videos. But it's still nice to just make some content that's a bit different and slow pace. Yeah, your honest opinion is very much welcomed. I will not be upset if you think this is a waste of time or it's going too slowly. You can also skip ahead if you want. There is some music. Well, there's some sound at the end of this video. Probably could have got away with just twisting these wires together and putting some electrical tape over them. Great shot, Tom. So that was a bit janky, that one, but again, hey, it works. I'm just going to jump ahead now because all I'm doing is putting a little bit of tape around that new joint I made. I've already done one. It's not the most exciting part of the project. This could be another good situation for some of that heat shrink stuff, if I could get some thin stuff. I'm assuming they make it super thin. Anyway, there we go. We now have some nice stabby breadboardable hole fillers for the second set of probes. And we can now go plug them in. So we're using that second row down, one into the 5 volts. Those resistors are moving around a bit. Whatever. And plug this one into the analog 1 hole. That should be good to go. I think I'm trying to give you guys a bit more of a close-up here. So yeah, bit of a mess. I think moving beyond 2 probes, I'm going to have to tidy this up a bit. Maybe get some kind of development board or something, or just be a bit more crafty. But that is our setup for 2 probes. We have the original one we did in the last video and the one we just made now. So let's get a bit codey. So now that we have 2 sensors, we're going to create a new int. We'll call this moisture sensor. We're going to call that 1 and we're going to rename the last one to 0. We're going to set moisture sensor 1 to analog pin number 1. We're also going to need 2 moisture values. So we'll call this moisture val. And we're going to call them 1 and 2. Anyway, we have for now. So moisture val 1 equal moisture value sensor 1, moisture val 2, analog read. What pin are we going to read? Moisture sensor. Come on, when am I going to spot the inconsistency of of my naming here? That's driving me a bit crazy. Yeah. So this needs to be moisture value 1, 0, and moisture val 1. We need to change these to 0 and 1 as well. Change this from moisture sensor 0 to 1. So now we're reading both analog pins A and 0. Gonna have to change how the printing or the output of these is, because now we have more than one. So I'm just going to go ahead and say serial print. We'll just go moisture val 0. And we'll keep that as moisture value 1. But we are going to have to separate these somehow. Just compiling it, and of course I've left a semicolon off line 13. So that all works, that all checks out. So here we are. Let's go ahead and plug the Arduino in. You'll see we have a second plant here. A lot of my plants are quite big, so I've borrowed this one from upstairs in the communal area. So plugging in the Arduino. Plug it into the computer. Now let's get these probes in properly. I've just kind of shoved them in very carelessly, but I'm just gonna put these in a reasonable depth and a reasonable width. I haven't thought too much about the width in which I put them in. I'm assuming it's going to make quite a difference. It should probably be pretty consistent for every plant. It looks like the one on the right is a bit more far apart than the one on the left, but anyway. So now those are plugged in, I'm going to upload the sketch to the Arduino. Or maybe I have already. Nope, we're uploading it now. And that's done. Now let's open up that serial plotter and have a look. So you can see we're only getting one reading in the serial plotter here, so this is where I realized that I'd done something wrong in the code. So that's not ideal. What we need to do is we need to separate those two values with a comma. So I'm just going to do another serial print. And we'll make this just a comma with a space on each side. Let's upload that one. And I forgot semicolon. Blah, blah, blah. Now let's check out serial plotter. And boom, we have 2 lines, one for each probe. You can see the red line is the second plant, and that's the probes that I just recently created. That's the plant on the right, and that's pretty much super watered already. The soil is incredibly wet and dense, whereas the succulent is really thirsty, so it's needs a lot more water. So I'm just adding a little bit more water to the probe on the right here, and you can see we get a slight bump in the red line, which is all good. Let's go ahead and add some water. I'm putting it right over the probe, and you can see that blue line jumping up as I add water, and there's a big squirt which raises it quite a lot. So good, we have 2 probes working, and we have 2 plants which are both very different watered values. So I'm going into max here. You can see we're now getting those 2 values as, I guess, a list separated by a comma. So I'm just going to separate those numbers by using this ZL slice object. So out the right inlet, out the right, out the left outlet, we're getting 1 value. So we'll connect that to the slider or the display. And we just need to change the ZL slice to a 2 so it gets rid of the comma, and now we get the second reading coming out the right outlet. So we can duplicate this across. And there, so plant on the right is this graph on the right, plant on the left. The succulent is the value on the left. And it's this stage I thought, okay, well let's get it making some sound, because that's what we want, right? We want to have some sound coming out of this at some stage. So we'll do some very basic kind of oscillation frequency triggers here. So I'm just going to add a cycle which creates a sine wave, and we'll just set the initial value to 440. It's not needed, but we'll do it anyway. And I want to have 2 of these. I don't know why, but I made the second one initialized to 880. And by simply connecting the output to the input of those cycles, we're going to be getting the moisture level from 0 to 1000 in hertz. So connect that to there, connect that to there. Now I do need to create some sort of way to output those sine waves, and the first thing I'll do is create a gain. This is just so we can have volume control, because otherwise it's going to be full volume straight away, and that's not going to be very nice. Just checking my audio to make sure it's turned on. Okay, you see we have a level, which is good. And let's just connect the second sine wave to another gain. Create an easy DAC, which is kind of an output from Max MSP to your sound card. And I'm just going to connect those like so. Let me just turn down the music. And there we go. We've got plant on the left, playing 1 tone. Let's give it some water. There we go. More water I add, the more it goes up. And I'll try the one on the right. Don't think we can get much more. I think that soil is saturated as it can be, so I'm going to try it just a little bit. Let's try this one again. Very good. So we have successfully connected 2 plants to the Arduino, sent them across to Max MSP. Max MSP is generating 2 separate tones based on the moisture level of the soil. And yeah, I think in the next video we're going to start exploring the potential of using the ESP32 and the screen. I'm not going to do another video where I'm cutting cables and doing bad solder jobs, because after doing this one I realized that that takes up quite a lot of the video time. So thanks for coming along. Once again, let me know if you're into this series. I'm just going to casually post these as I make them when I get the free time, and I look forward to seeing you in the next video.